G'day Year 9, just thought I'd scare you with a close-up there. Looking at some applications of trigonometry, so nothing really new to learn, just practicing applying our rules that we already know, which should be pretty good. Let's have a look and see how we go. Just running over what they're going to talk about here. Possibly new to you is just a couple of terms. Is talking about going from a horizontal line and angling up, always from the horizon up, or an angle of depression from a horizontal line and angling down. Always measure from the horizontal. You've got a couple of examples there. You can see that very clearly. How are we going to do these? We're going to draw pictures, label our sides, do what we do for every trigonometry question we've ever done. Let's have a look. Oh, I might need to insert a little bit of space. That's about the only thing we might need here, just to make sure it's not too cramped up when we go to have a look at this. So, the angle of elevation of the top of a tower from a point on the ground 30 metres away from the base is 28 degrees. Find the height of the tower. So I'm looking for the height, and I know that this is 30 degrees. Well, let's label our triangle. There's my right angle. So this is going to be the hypotenuse. Across from the angle is the opposite side, and next to the angle is the adjacent side. Now I pull out of my pocket SOHCAHTOA, and that reminds me what I want to do. So, which sides do I need? Well, I'm looking for the opposite side, and I know the adjacent. I need the tangent ratio. So, I can start by writing the rule if I want. That pen is still playing up a little bit. Here we go. The tan of the angle that I'm going to be used is equal to the opposite side divided by the adjacent side. And now let's fill in the blanks. The tan of 28 degrees is equal to the opposite side. Well, I can use, they've labelled it h for metres, so I can call it lowercase h. I won't confuse that with hypotenuse. And the adjacent side was 30. So now 30 tan 28 is the height. Therefore, the height is approximately equal to, have I got a calculator here today? Good news. What do we have to check? That's right, you have to make sure you're in degrees mode, that it hasn't actually changed. Mine looks like it is, so that's good news. So 30 tan 28, hit the equal sign, and that's approximately equal to 15.955 metres. Yes, I told you that stylus is playing up, but I'm going to persevere. We're nearly there. Now it says in the question to the nearest metre, so I can say approximately 16 metres. And had I left myself enough room, I might even write a nice little sentence there. It's that easy. It says for you to try this one, but I'm going to help you out again. The angle of elevation to the top of a tree from a point 50 metres away from the base of the tree is 32 degrees. You can pause it now if you want. I'm going to talk through this one though, rather than just show you the answer. Well done to you if you did pause it. If not, here's how I'd go about this one. Here's my tree. I'm an amazing artist, as you would imagine. 50 metres away. Yes, probably none of you imagined, nor did I. But that's okay. 50 metres away, the angle of elevation to the top of the tree from a point 50 metres away from the base. Okay, it was just a bit confusing. How could you have an elevation from the base? But there we go. There's my 32 degrees. What am I going to do? Label it. My right angle would sit in there, wouldn't it? Okay, so this is going to be the opposite side. We know that's the hypotenuse, and we know this is the adjacent. It's exactly the same rule as we had before. So I can start by saying the tan of 32 degrees equals the opposite side. Well, I'm just going to leave it as the opposite side this time. Divided by 50. 50 tan 32 equals the opposite side. They want to know to the nearest metre. That's approximately equal to 50 tan 32. 31.24 metres. Therefore, that's me right, is approximately 31 metres tall. Nearest metre, we've done that. That's all you have to do. Couple more here to try. They're not going to be any different. It's just going to be doing the same thing over and over again. I will work through 15 and then I'll give you a chance to try the others. Let's have another look. Might change my pen. Maybe it's the colour of the pen that's causing all the issues. I doubt it, but why not? A little bit of Gould pride. For example, 15. From the top of a vertical cliff. Here's a vertical cliff. Not many cliffs are actually vertical. Let me draw. There we go. You can even label it cliff if you want. From the top of a vertical cliff, Andrew spots a boat out at sea. There's my amazing little... Oh, let's make it a cruise ship. I'm sure they're all very happy to be cruising and not at all worried about catching anything too soon. And she sees that the boat is about 90 metres away from the base of the cliff. The top of the cliff is 42 metres high. Okay, this is 42 metres. Somehow she can tell that that's 90 metres away from the base of the cliff. I'm not sure anyone could do that, but there you go. And we want to know the angle of depression. So that's what I started drawing there, was the horizontal line, because I know that angles that I'm after are measured from the horizontal up or down. So an angle of depression from the horizontal down. I want to know that angle. It's not actually part of the triangle I've got there, is it? So I could redraw the triangle and say, well, if it's 90 metres away that way, I could put the triangle upside down on top there, and that would still be the same. That'd be 42 metres high and 90 metres away. But I think it's probably easier just to say, oh, alternate angles, this angle's going to be the same. Oh, that makes it easy, doesn't it? So now 42 becomes the opposite side, 90 becomes the adjacent. Oh, it's another tan one. Not very creative in giving us a bit of variety here, Cambridge, but that's okay. Let's insert some space and let's go ahead and write it. So tan of theta equals the opposite side, 42, divided by the adjacent side, which is 90. Remember, when finding an angle, we do arctan, the inverse of the tan function, arctan. Theta is approximately equal to, so arctan, what do? That's right, your shift button, then your tan. Should look like that on your calculator. Arctan, use your brackets, 42 divided by 90, close the bracket, equals, and that's saying approximately equal to 25.01. Well, they want it to the nearest degree, so let's just write it, approximately 25 degrees. All there is to it. All right, so you can use this to find angles as well. I think you're fine to do this. You don't want to sit through any more of a video. You want to get stuck into your maths. Hopefully you're watching these on 1.5 speed, because I know that sometimes it's a little bit slower. Good luck. Keep the questions coming if you have any. Otherwise, get stuck into your work. Thanks, guys.